Hello guys, today we are going to learn how to use our CAD tool, that is Eagle Design. Eagle is freely available on Autodesk website. You can download it from there and perform all your lab experiments. First of all, we need to create a new schematic sheet. For that, click on File menu, New and Schematic. A new schematic sheet will open in front of you that contains a toolbox on its left side. By default, Eagle has thousands of component libraries, but some libraries are not directly available. So if we want to use a library that is not available in Eagle, we can add it manually. For example, in this circuit, we are going to use a microcontroller that is 80Tiny45 that is not available in Eagle by default. So we will add the Tiny45 microcontroller to the Eagle first, then we'll continue with our circuit. For that, first of all, go to the google.com and type 80Tiny45 library for Eagle. Here you will see a link of diymodules.org. Click over there and a library of HH and 80Tiny 25, 45 and 85 will bring in front of you. So download original file from here. After download, right click over there and show in folder. So here is the download folder. Copy this library and come back to the Eagle. So here go to the library, open library manager, go to the available and browse. Here you can see there is no library, so right click, paste. So open it, select it and use. Now close this. Also close this. Now you can use the 80Tiny45. Today we are going to design the PWM transmitter circuit that we have discussed in last video. For that, firstly we need all the components of PWM transmitter to be here. To bring all the components, here is a tool named Add Part. Click on Add Part tool and new pop-up window will bring in front of you. It contains the option of search. Here you can search for any components. Like our first component in the PWM transmitter is DC jack. So I will search here for the DC jack. DCJ0202. It's a code for the DC jack. That was same mentioned in the schematic diagram. So click on DC power jack. Okay. Now it has connected to your mouse cursor. You can place it anywhere in the screen. After placing it, press the escape button. After escaping, you will come back to the add part section to search for the next component. Our next component is voltage regulator. So that is 78L05Z. This is our voltage regulator. So I'll bring that to the screen and place it over here. So next we need some capacitors. So here is the huge categories for capacitors available. From this we are going to use the first one, expand this category and use any capacitor from here. Don't bother about the value of capacitor now. So that value we can change later in the schematic screen. So after capacitors, next we need a microcontroller. Our microcontroller is Tiny45, so I am going to search for that. So here is our category for 8045. Select Tiny45 from here and OK. Now you can place this over here. Next we need a resistance and LED that will be connected to the microcontroller for indication. For resistance, I will type resistor. Again, a huge amount of categories available for the resistance. From here, we are going to use RUS. From the RUS category, you can use any resistance Same, the value can be defined later. To rotate any component in schematic screen before placing, press the right click. Now with right click you can rotate 90-degree component. So next we need LED. So here I'm going to use a 3 mm LED. So I'm typing LED 3 mm. So here is the 3 mm LED that will be connected to the resistance. Next, last component we require are PCB headers. There is a code for PCB headers 22232031. When you add this code, a category of PCB headers will bring in front of you. Select this. We require 3 PCB headers, so I will place it 3 times. 1, 2 and 3. So we have bring all the components over here. Now next we are going to do the connections of these components. For connections we require a tool that is net. Net is a connecting wire that will join all the components. Select the tool and start joining. Firstly, we need to join the positive terminal of DC jack to the input voltage and the negative terminal of DC jack to the capacitor. Negative terminal of the capacitor. It needs to be on both capacitors. Now you can see here a dot has been generated. This is called junction. When any path splits into two paths further, a junction is created over there. Need to connect the positive end of capacitor to the input voltage and the another capacitor is to be output. There is a ground pin of voltage regulator that should be connected to the ground. So we have done all the connections of voltage regulator. Next we are going to connect it with the microcontroller. Here the 8th pin of the microcontroller is positive VCC that should be connected to the output of voltage regulator, and 4th number pin is ground that should be connected to ground. So we have connected the microcontroller to the power supply. Next there is a pin number 1 that is negative reset. In the schematic we have seen it should be connected to the VCC to prevent the auto reset. So we have connected first number pin to the VCC. Now we are left with 5 general purpose input output pins that we have programmed for our specific task. In this we have connected pin number 2 to the LED for the indication. So we are going to do the same to the resistance, and after resistance there is a LED. Next, now we have to connect the PCB headers. In the case of PCB headers, a thing to be noted in mind, the first and the last pin of PCB header should be connected to each other for the both headers. We'll do the same for the third also. After connecting this, now we have left with only 2 terminals. This is the positive terminal and center one is ground. So we will connect all the positive terminals to the pins of microcontroller. Suppose with pin number 3 there is a connection of first header, with the pin number 7 the another header, and with the pin number 5 the last header. So we have connected the headers to the microcontroller circuit. Now in the last we need a ground connection to be connected to LED and all the 3 PCB headers. So we have the ground over here. Firstly we will pick from here and connect to the LED directly. So we have connected LED to the ground. Now we will make junctions from in between. So we have created the 3 connections, that is ground for the PCB headers. After this we have almost completed the schematic diagram. The last step we need to do over here is to give the values to capacitors and resistance, because there should be a value of these components. So to give the value, right click on the component and there is an option of value. You can manually define the value of every component over here. So in our case here it is 1 microfarad. The another capacitor is 10 pf, so we'll just type 10 pf, and the value of resistance is 330 ohm. So we have defined all the values. Now we can check for the errors. Here is a tool in last that defines ERC. ERC is basically electrical rule check. We'll click over here and it will show if there are any errors or warnings in the circuit. So there is 0 error and it's showing 3 warnings. Let's see what are these. It's saying power pin is grounded and power pin VCC is connected to VCC. That should be right. And LED has no value. Similar, LED doesn't need any value. So it's all clear. So next step we are going to do is to save this schematic diagram. Save. I'm giving the name PWM transmitter. So we have saved this schematic. Now we have to create a PCB layout from this schematic. For that, go to File menu and switch to Board. After clicking, it will ask you to create from schematic. Press yes over here. Now you can see there is a black box appears over here and all the components we have connected are bunched on the right side. Here are all the components that we have used and this is the blank PCB. Now we have to arrange all these components to the PCB according to ourselves as our requirement. So first of all, I'll start with the DC jack. I'll connect DC jack or is here. You can rotate any component by right click over here also. Next I'm going to place the microcontroller. It's the main component of this circuit. So I have placed the microcontroller over here. Next, voltage regulator. It should be placed over here. Next is the capacitors that are connected to voltage regulator. I'm going to place it over here, and for the another one it should be placed over here. Next is our resistance that is connected to the LED. So I'm going to place it over here. Next is our LED. It's over here. Next we are left with the PCB headers. Now first one, I'm going to place first one over here. The second one, after rotating over here, and the third one over here. So we have arranged all the components according to our requirement. Our next step is to reduce this PCB size to prevent the wastage. Make sure it stays rectangular. So we have arranged the PCB size. Now we need to define a safe area for this PCB. That is defined by the polygon tool. Click on polygon and start from one edge of the PCB, moving towards the sharp ends of the PCB. For the signal name, leave it blank. Now last and most important step is to route all the connections for this. For that we are going to use auto router. There is auto router tool that will create automatically best connection for this PCB. Continue and start. Here it will show us the best 5 routes that can be implemented in this PCB. You can change between these 5 whatever you like. So you can check all the 5 and go with any best route you find. According to me, for me, it's it seems good to me, so I'm going with this one. So after that, end job. Here you can see all the connections has been made, but there is a difficulty to see the connections because we are having the top look. From view from bottom, select the bottom layer. So here is the bottom layer. Now you can see all the connections properly. The blue connections in blue color are on layer 1, and here is a connection on black that is on layer 2. So it's a multi-layer PCB that can be work on different layers. So this is all about the software and our first experiment of PWM transmitter. Thank you.